let's go over this one. You notice number one, as you finding an equation of a line like we talked about yesterday and did on homework last night, and then 2, 3, and 4 takes you back a little bit to some algebra 1, algebra 2 kind of stuff, or trying to find x and y intercepts. So number one says find the equation of a line that passes through the given point and happens to be perpendicular to a line that goes through these 2 points. So we said yesterday, perpendicular lines we know about. Slopes opposite reciprocal. Yesterday we did an example, I think, that involved a parallel line. Parallel lines have the same slope, but lines that are perpendicular to each other have slopes that are opposite reciprocals. And so we know that the line that we're trying to find is perpendicular to a line that goes through these 2 points. So we can find the slope of that line, and then from there we can determine the slope of our line. So to find the slope of the line that goes through the points 1/2, 2/5, and 4, -4/5, we said yesterday we're going to do the change in y over the change in x. So I can do 2/5 minus -4/5 over good question. What if I did -4/5 minus 2/5? As long as down here in the denominator I did 4 minus 1/2, that'll be fine. Okay, so it doesn't matter which order I do those points, which one I consider x1, y1, x2, y2, as long as I'm consistent. So if you did -4/5 minus 2/5 over 4 minus 1/2, you're going to get the same. Okay? 2/5 plus 4/5 would be 6/5. 1/2 minus 4, 7/2. Okay? If you reverse those, you got -6/5 over -7/2, but the negatives cancel out, so we're going to end up with the same thing. If you used your calculator, that's fine, but just some pretty simple arithmetic. When I divide fractions, I really multiply by the reciprocal. So I'm going to get 14 over 35. So there's my slope, 14 over 35. 6 times 2 is 12. How about that? Yep, all right. Off to a good start here. So let's make that 12 over 35. Thank you very much for that. And so there's our slope. And if that's the slope of the line that goes through these 2 points, then what's the slope of the line that we're trying to find? -35 over 12. And now we have the slope of our line. We have a point on our line, that -3, -7. And so therefore, when we want to write the equation of a line, we can use point slope form, which will just be y minus a -7 equals -35 over 12 times x minus a -3. And thank goodness it didn't tell us to put it in slope intercept form or anything like that, because that's the way we can just leave it right here in point slope form. Everybody good on number one? Number two, again, we said to find the x and y intercepts of these the following, and it also asks you which of these were functions. Okay, so we had to do a little bit of thinking here. First we had to remember how we go about finding x and y intercepts, and as Jalen said, you set the opposite coordinate equal to 0. So when I want to find the x-intercept, what that really means is the graph is crossing or intercepting the x-axis. And if we're sitting on the x-axis, that must mean our y-coordinate is 0 because we haven't gone up or down it. So if I want to find the x-intercept, I plug in 0 for y. So what's my equation going to look like when I plug in 0 for y? Good. 9 times 0, 7 times 0, those will cancel out. So I'm really just going to be left with 5x squared equals 125. I've gotten that by plugging in 0 for y. I can solve this for x. I'll divide both sides by 5. And if x squared equals 25, then what does x equal? 4. Or -5, right? You got 5 or -5. And remember, when you solve this, You know, it's like taking the square root, and when we take the square root of both sides of an equation, we've got to put the plus or minus with it. Because if I took -5 and squared it, I'd get positive 25 as well. And so we have to include both of those answers. So we have two x-intercepts here, 5, 0, and -5, 0. And then we'll find our y-intercepts. And to find our y-intercepts, what do we do? Okay, plug in 0 for x. Okay, so now when I plug in 0 for x, I'm going to get 5 times 0 squared, which is 0, plus 9y equals 125 minus 7y. Yeah, pretty simple linear equation to solve. We'll add the 7y over and then divide by 16. So looks like our y-intercept will be 125 over 16. There are x and y intercepts. Any thoughts about whether or not that represents a function or not? I guess that means that we got to remember what a function is. Try to remember a good definition of a function. It's like one of those things, I know it when I see it, right? If I gave you a graph, you could say, yeah, that's a function, or no, it's not a function. How do you know if it's a function or not by looking at its graph? What do you mean it makes a line? Henry, you're over there thinking. You're going, anything? All right, something about coordinates not repeating. All right. Yeah, we call that the vertical line test, right? And the vertical line test says that if you can take a graph or take a pencil or a vertical line and drag it across your graph, if at any point that line touches the graph twice, then it's not a function, right? So that's always been, I know it when I see it, right? Because I'll say, like if I were to give you a graph like this, you'd say, not a function, because I can draw a vertical line that hits that graph in two places. Not a function. But if I gave you this graph, you'd say function, because there's no vertical line. You know, when I draw that vertical line across, or that pencil test, as you said, draw it across. There's never a time when a vertical line is going to hit that graph in more than one spot. Okay, so let's get back to what Emery was saying. She was saying something about repeating coordinates. Over here, in this one, I've drawn the vertical line in red. At this point and at this point, where that vertical line touches the graph, what's going to be repeated? The y coordinate. Okay, it's going to have the same y coordinate. No, I'm sorry, you're right. It's the same x coordinate. Yeah, like you said, same x coordinate. So at this point, maybe I don't have my little markings on here, but maybe like it's going to have a point -1, 4. I'm just making this up, and this one might be -1, -3 or something. But what we see there is that vertical line hits that graph in 2 points, and at those 2 points has the same x coordinate. So Emery was right. It was do you have repetition in your x coordinates? In other words, do I have one x coordinate that goes to 2 different y coordinates? Okay. Well, in the example that we have here, we haven't found a whole lot of points. Okay. All we have found are some x coordinates and a y coordinate. Just based off of those points, do you have an x coordinate that matches to 2 different y coordinates? No. I mean, I have one y coordinate that matches to 2 different x coordinates. 0 matches to 5 and -5. But a function has to, or for it to not be a function, there has to be a match of one x coordinate to 2 different y coordinates. So far, do you think this is a function? Yeah, okay, I'm going to say yes, maybe, you know, whatever. But based on what we're seeing so far, it looks like it could be a function. Okay, we'll come back to it in just a second. All right. Let's go to number 3. Number 3, we have 4x squared minus 9y squared equals 16. So let's find our x-intercepts, which we've already said that occurs when y is 0. So I'm going to plug in 0 for y. I'm going to get 4x squared equals 16. That's a pretty easy one to solve. X squared equals 4. So x must be, or yeah, we can just say plus or minus 2. So we have 2 x-intercepts again, like we did back in number 2. And then for our y-intercept, y-intercept is when x is 0. So when I plug in 0 for x, what's my equation look like? Negative 9y squared equals 16. So y squared equals negative 16 ninths. What's y there? The square root of negative 16 ninths. What's the square root of negative 16 ninths? Yeah, an imaginary number, right? Remember back in algebra trig, we said if you take the square root of a negative number, that's imaginary. We can't do that. Okay? In fact, the reason that it is if I use a little common sense here, what happens when I square something? What happens to it? Multiply by itself, and what about its sign? It's got to be positive, right? If I take 2 positive numbers and multiply them together, I'm going to get a positive. If I take 2 negative numbers and multiply them together, I'm going to get a positive. So if I'm squaring something, there's no way it can equal a negative number. Okay? And so that's where imaginary numbers came in. But when we talk about graphing, we're not going to graph imaginary numbers. So what that means in this case is there are no y-intercepts. No y-intercepts. Now, had we actually gotten a value out of that, when we take the square root, what do you remember from algebra trig about taking the square root of a negative number? You said it's imaginary. So you probably just put the I there, and then you did the square root of 16 ninths. And that one we can just do the square root of the numerator, which is 4, and the square root of the denominator, which is 3, and of course we would have got a plus or minus. So we would have gotten plus or minus 4/3 I. But that's an imaginary number, and we don't have imaginary intercepts. So we just ignore that and just say there are no y-intercepts. All right, what do you think about the function here, function or not? You're not like it. If you don't like it, why not? Yeah, it's still got an x-intercept, so there is a graph. It just doesn't have any y-intercept. So it means that, let's think. Graphically, I know that it's going to intersect the x-axis at 2, and it's going to intersect the y-axis, at negative 2, the x-axis at negative 2. But what I know about my y-intercept are there are none. So this graph does not touch the y-axis at all. It could be a horizontal line, but it can't touch that y-axis. So I can't do this because I touched it there. Then you have 0, 0 as a y-intercept. We don't. So it can't touch the y-axis at all. So, do you think you could draw a graph that goes through these points and never touches the y-axis and is a function? You can't? I could. I could do that. Huh? No, you don't touch. It's called a piecewise function. You did piecewise functions back in algebra trig. Yeah, so I could do that. But I could also draw a graph that goes through those x-intercepts and is not a function. I could do this. Goes through those points and it's not a function. Right? So what is it? It's a maybe. Maybe it's a function. All right, I like maybes for a while. And maybe. Oh, there. Oh. It depends. It's the functions are in the eye of the beholder. Yeah. Okay. All right. Yeah. This is still math, and the answers are always yes or no, right? But for now, we're gonna say maybe. It depends. We'll see. All right. We'll come back to that. All right, number four. Oh, absolute value function. Man, remember how to solve those? All right, let's see. X-intercept. We want to find an x-intercept. We plug in 0 for y. And when I plug in 0 for y, I'm going to get 5 times the absolute value of x minus 4 plus 0 equals 5x. Solving an absolute value equation. Get the absolute value by itself. So divide by 5. All right. Absolute value of x minus 4. 5x divided by 5 is just x. And then close. Very close. So you've got the right idea. Remember that absolute value, you got to do two separate equations. Just think, when I have the absolute value of x equals 2, what could x equal? X could equal 2, or it could equal -2, because remember that random mathematician at some point said put straight lines over a number, it becomes positive. So if I put straight lines over -2, then it's going to become +2. So we do split it into two separate equations, but we changed the wrong sign there. We're not going to change that minus sign between x and 4. Instead, we're going to just copy the x minus 4 and set it equal to positive x. And we're going to copy the x minus 4 and set it equal to negative x. Good. And we're going to solve those two equations. All right, so if I solve this equation, I'll subtract x from both sides, which leaves me with -4 equals 0. Well, that doesn't make any sense, so forget that one. And then over here, I'll add the x over. That's going to give me 2x. I'll add the 4 over, and so x must be 2. Okay, so there is my x-intercept. Okay, and you can see if I plug 2 in for x, 2 minus 4 is -2. The absolute value of that equals 2. That makes sense. Okay, so 2 is one of our x-intercepts. All right, or is our x-intercept. It's our only x-intercept. The others. Our y-intercept, we'll plug in 0 for x. All right, when I plug in 0 for x, I've got 5 times the absolute value of 0 minus 4 is -4. So that's just going to give me 4 plus 8y equals 5 times 0, which is 0. So that's just 20 plus 8y equals 0. I'm going to subtract the 20 over. I'm going to divide by 8. So I've got -20 over 8. I think that reduces to -5/2. And so there's our y-intercept, -5/2. Everybody okay there? Yes. Yeah, so right, when we can take the absolute value bars off when we say that that absolute value is equal to both the positive and negative value of the other side. Yep, good. All right, everybody good with that? By the way, this -28, if you wrote that up here without reducing it, I'm not going to worry about that anymore. You know how to reduce fractions. You did that back like in elementary school, maybe middle school, right? If you forget it, I'm not going to stress that. Okay? And the reason being is that on the AP exam for calculus, they don't care if you're reducing them. So I'll let you leave it as -28. But if you want to go ahead and reduce it, that's fine too. All right. So either negative 28 or negative 5 halves for your y-intercept is fine. All right, what about this one? What do you think about this as a function? I got one x-intercept, I got one y-intercept. Let's see. Feeling good about it? All right. Do you think that it's possible that maybe it's not a function? Or are you 100% locked in function? You think it could not be a function? Do you think I could draw a graph that goes through those 2 points and does not pass the vertical line test? I bet I can. Yeah. Let's say, what do we have as our x-intercept? It's 2? Yeah, okay. Do you think, what was our y-intercept? Negative 5 halves? That's like negative 2.5. I bet I could do this. That wouldn't be a function. Right. How would I know that? Right. How do I know that by looking at the graph? I just am making stuff up. Right. So, but at the same time, I could also draw a graph that goes through those points and is a function. Like I could do this. That's a function, isn't it? So which one is it? Parent. What do you mean parent functions? Let me ask you this. Looking at this right here, what do you think the parent function would be? You have a parent function you're kind of familiar with. On number 4, the x would be no. Parent functions, yeah. Yeah, this looks like an absolute value, right? Do you remember the parent function y equals the absolute value of x? What does that look like? Yeah, v, right? Y equals the absolute value of x looks like a v. Is that a function? Yeah, it is. Yeah, it is. It doesn't repeat x values. It repeats y values, but it doesn't repeat x values. So it's a function. Go back to number 2. What parent function does that kind of remind you of? Yeah, y equals x squared. What does y equals x squared look like? A parabola. Is it a function? Yeah, so 2 and 4 are reminding me of parent functions that actually are functions, right? Things that you've learned before. Does number 3 remind you at all of any function you've ever seen? No, because I don't think for any parent function we've ever had y squared. Can you think of one? No, because all of your parent functions started off with what? Y equals something, right? Y equals x was a line. Y equals x squared was a parabola. Y equals the absolute value of x was the V shape. Y equals what else did we have? X cubed, that was a cubic function. Y equals the square root of x. We've graphed those before. Y equals sine of x, cosine of x, tangent of x. You might have graphed those in algebra. But in other words, every single one of our parent functions started with y equals. Okay? And that's how you can really tell whether or not it's a function. If you can get y by itself, then it's a function. Okay? If you can get y by itself, it's going to be a function. So I might have to do a little bit of manipulating in 2 and in 4, but I could get y by itself because I could add the 7y over, I could subtract the 5x squared over, I could divide everything by 16. Now I have y equals all by itself. I could graph that on my calculator because I could click on the y equals button, and then I could type it all in, and I could graph that joker. And same thing for number 4. I could take this absolute value and subtract it over. I could divide everything by 8. I'd get y by itself. And boom, I could put that in the calculator and get y equals and graph it, and so it's going to be a function. Your calculator only graphs functions. That's why it's a y equals button. It doesn't know how to graph anything else. It only graph functions. So 2 and 4, yes, they are functions. But number 3 is not. Now, You know, that you might say, oh, wait a minute, that kind of contradicts what he just said. He just said if I can get y by itself, it's a function. Well, I can get y by itself. I could subtract over that 4x squared. I could divide everything by -9. Take the square root. But there's the problem. When I take that square root, what happens? Not necessarily. Not necessarily. Hmm? Well, I would have y equals, but what happens when I take the square root of both sides? Get plus or minus. I'm going to get plus or minus the square root of blah, blah, blah. Okay? Y is not by itself, even though it looks like it, because it's y equals to a positive blah, 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 and y equals a negative blah, blah, blah. Okay? It's equal to two different things. It's not equal to one thing, one expression. It's equal to two different expressions. If I were going to put this in my calculator, I'd have to put positive square root of whatever in y1, and then negative square root of whatever in y2, and so I'm going to have two different graphs showing. And it's going to end up not being a function. So really the rule here on a function is, can you get y by itself? And I'm even going to take that a step further. When we graph something like y equals x squared, you've already told me what that graph looks like. Y equals x squared. That's the parabola. Anybody want to venture a guess as to what x equals y squared looks like? Sideways. Yeah, it's sideways parabola. Because, again, what happens if I take the square root of both sides to get y by itself? I get y equals plus or minus the square root of x. In other words, the positive square root of x that you graphed before and the negative square root of x that you graphed before. Is that a function? No. Okay? So when x is squared, it's that parabola that opens up. But when y is squared, it's a parabola that opens sideways. And the same thing's true of absolute values. You know what y equals the absolute value of x is. That's the V shape. But what do you think x equals the absolute value of y might be? A sideways V. Exactly. Not a function. Right. So really what's happening is there are x values that are giving me two different y values. Like, for example, the x value 4 on this graph, when 4 equals y squared, that means that y could be either 2 or it could be negative 2. And same thing here. If x is 4, that means that y could be either 4 or negative 4. There's that one x value that's going to two different y values, making it not a function. All right, so I'm going to boil it down for you. Okay, here's what you're going to put in your notes about functions. Okay, here's how we're going to know if an equation represents a function or not. We can say that an equation represents a function if y does not have an absolute value or an even exponent. So an equation represents a function if y does not have an absolute value or an even exponent. Can we have absolute values over x? Sure we can. It's still a function. Can we have x raised to an even power? Sure we can. But when y is raised to an even power, or when y has an absolute value on it, now it's going to take those graphs and make them open sideways. And now it's not going to be a function. So when y has an even exponent or an absolute value on it, then what's going to happen is that means there's going to be one x that's going to lead to multiple y values. And in that case, not a function. Now, what about when y is raised to an odd exponent? Well, let's say that we have the equation y equals x cubed. I bet you remember that from algebra. Yeah, I mean, it looks kind of like this. Little squiggly line. Okay. Well, what do you think the graph looks like if it's x equals y cubed? Yeah, it's just going to be kind of turned on its side. But is that still a function? Sure it is. Okay? So it's okay when y has odd exponents. It's only when y has even exponents that it's not a function. So you can, remember we said about functions, I know it when I see it. In other words, if I give you the graph, you got no problem telling me if it's a function or not. But now, we don't need the graph anymore. We can just look at the equation and say if it's a function or not. And we're going to say by looking at that equation, I'm going to look at all the y variables that are in that equation. And if any of those y variables have an even exponent or have absolute values over them, boom, not a function. Okay? So now, really easy to answer the question, are these functions? And number 2, function. 3, 4, you got it. Okay? Any questions on the class starter? All right, good.